we'll be talking about Pandas today, and then Pandas is a library which we use in Python. So I'll be starting right now. So we are just going to visually talk about the introduction to it, and then we will dive in deep. But today I want us to use Pandas in just Google Collaboratory. Like I said, Pandas is just like an open uh, source library in Python, which we use for data manipulation and data analysis. So it gives us this opportunity to have a kind of data structure and function. So we can handle any type of data structure and function in tabular form, like I said earlier, like Excel or SQRL. And then in terms of data structure, we should be looking at the series, that is one dimension types of data, and then we're also going to be looking at two-dimension types of data. And in terms of data operation, we should be looking at filtering, we are going to be looking at sorting, we are going to be looking at grouping, we are going to be looking at merging, that is concatenating, merging different data. We're also going to be looking at reshaping. So we are also going to be looking into input and output, and then that is reading and writing CSV file, Excel file, JSON, and other types of different types of other data formats we are going to be looking at. We're also going to make a different types of analysis, which include statistic analysis like statistic functions, and then we can also do something like data cleaning and pre-processing. So there are a lot of things we are going to do as related to data, but one of the advantage of using Pandas is because it is very very fast and memory efficient. Like when you have a big extent of data, you can actually analyze the data with speed, like read what you have there and able to see what is there. And you can also change, like it have a kind of flexible structure. So like I said, we can use it for different analysis, like we can use it for data analysis, you can use it in data science, which include machine learning, statistic modeling, and even data mining. We can also use it for example like business intelligence. We can also use it for reporting, dashboard creation, and then data visualization, because we are going to do a lot of things. So I can show you how you can create a dashboard where you can automatically monitor and then be able to use that at will at any place you want to actually work on. So if you look oh, okay, I shared one of my screen, I think. So if you look at my screen, no, you can see this is a dashboard, a financial dashboard which I created. So and I'm able to link it with different data sets. Yeah, so with I think I'm not sharing the right screen, right? Let me, how do they stop sharing? So let me go here and they say share, stop sharing, share again, entire screen, okay, and click OK. Yeah, and then I think you can see my screen now. So if you look here, this is a kind of financial dashboard which I created for a particular working space. And if you look here, for example, you can see that I can sort whatever that happens. So for example, if I want to see what happened between 1st of January to today, I can just click apply, and this was able to show me that, oh, they have spent 4 million, and then this is what have happened within this date range, and this is how the money was spent. Then if you also look at this kind of dashboard, this is the dashboard which we use in monitoring electric data capturing. So you see it is automatic. I can design this kind of kind of dashboard while I am sleeping. It is there working for me, so I don't need to do anything on it. So for the fact that I created it, that kind of this can actually be there for me anytime, and I don't need to keep on repeating what I'm doing again. So you can see it is an interactive dashboard. So what I'm saying in essence is we are going to be using Pandas for different purposes. Now in here like Google Collaboratory, like we have been using, we can see here, you open your Google Collaboratory the way it is, and if you click on code, you can see here you can type your code. By the left hand side here is where you have the table of content. Here is where you're going to search, find and replace. Here is also where you're going to have your data. Like I can upload the data I want to use here. Like this is Nigerian CSV. I can decide to delete it, so which I'm going to delete. So this is going to get out from here. Now what it means is that I can interact with my PC, like my personal PC. That is what I mean by PC, is I can interact with my directory by staying on this phase. Now for example, because we are going to use this, so I want to import the data and we are going to use that to demonstrate what we are going to do tonight. So in this case, I don't need to explain this interface. Are we together? Are we still here?
Yes.
Okay, so I don't need to interpret this, but if you have any issue, you can raise your hand and then tell me that you need explanation on any of what I'm doing. But for example, I have a file. I am going to bring a file, an Excel sheet here, a CSV file here. So I'm going to say from Google but collaboratory. So I want to import my drive. I can decide to click on this, and this is going to import from drive, but I don't want to import it like that. So I want to say from Google Collaboratory, I want to import files. Now I don't want to mount anything on my drive because I can access my drive, that is Google Drive, from here, but I don't want to access my Google Drive from here. So I am going to import the file. So I'm going to call this thing upload. Now upload is going to be file dot, that is the files I use here, dot upload. Now with this, as you can see here, with this simple 2 lines of code I put in here, if I run this code, what is going to happen is that I should be able to access my PC. So if you can see here, it is running. It is asking me to choose a file I want to upload, and it's asking me here to cancel upload. Now we are going to use this data we used earlier when we were working on symbology. Remember when we talked about, I can't remember the particular date, but we worked on using this data where we created the population data and able to show the spatial differences of this data. If you all can remember, we use this data. So I am going to copy the location of this data by clicking here and right click and say copy to clipboard. Now return back here, and you see here it is still asking me with this code, as you can see, from google.collaborate import files, and upload is equals to files.upload. Now with this particular file, I can click on choose file here, and I'm going to paste that particular Excel sheet which I copied, and now it's going to upload, and you can see it is done. So it says CSV file, last modify, this is the date, and then it save it as CSV file. Now if you go here, let me zoom out a bit. If you go here, you can see that if I refresh this, you can see that this CSV file is here already. Or I can click here to upload. I can click here to refresh. I can click here to mount on my hard drive. So I can be interacting the data that I uploaded in my drive here. So I can upload, I can refresh, I can mount, and I can also show, turn off or turn on a hidden file. So this is a way I can actually get this done. So if you see here, the file I have uploaded is here, which is Nigerian file. I can upload a picture, I can upload whatever I want now, but that's not what we are talking about now. So you can see these 2 lines of code. I was able to upload this Excel sheet. Now I'm going to start again. Now because we're going to use pandas, so I'm going to import pandas as PD. Remember what I said? I can use these pandas as PD as Kingsley. I can use these pandas as anything, but the default or what we have been using is import pandas as PD. Now, after this, what else am I going to do? I'm going to read this Excel file. How do I read CSV? The keyword for reading this CSV have to be, I can call the data whatever I want, but let me call it DF, and I'm going to call it DF is equal to this Nigerian shapefile, which is nigeria.csv. So I'm going to read this file as nigeria.csv. Now, let me remove this because I want us to understand something here. Now, when I run this, what happens? I have successfully called which is this particular thing is used for reading this file. Now, inside here, remember the name of this file here now, this Nigerian CSV. Anytime I say DF, it means I am referring to this Excel sheet here, which have the population of Nigeria from Abia at 0 down to 37 states, which is FCT. So we already know how this comes about. But if you look here now, you see that if I say here df dot head, this is going to give me the first 5 file as inside that CSV. Now let's look into it. This is 0 Abia 28530 and 30. If you go to this Excel sheet, you can see that Abia here is 2853038144943, which is exactly what I have here. Now, what I want you to understand is that the head here, df is the data which were imported, dot head here in parentheses gives you automatically the first 5 lines of that particular file we are working on. Now, what I'm trying to say is this. Even if you have, this is easting and nothing, even if it is Excel sheet, the data you wanted to plot about your coordinate, I used to plot contour using this. I can just do contour. The good aspect of this, which I'm going to be telling us, is this. The moment you have a file you want to plot, let's say you want to produce a Nigerian map, for example, showing population distribution, or you want to create a Nigerian dynamic map that you hover and you get a population. Now, you don't need to repeat that same thing again. Tomorrow, what I just need to do is to come and import again and run it again. Automatically, I will get that. Is it, you are raising your hand? Go ahead, Stephanie.
Please, can you what or at some point I saw fair breaking, so I didn't hear most of it.
Okay, what? Where did you stop hearing me?
When you showed us that what that is leading to that Excel file. After that place, I wasn't really hearing you again.
Okay, so I was saying that the
On
way
the
you
Excel
can
sheet.
read, yeah, the way you can read the file imported is using df is equals to pd is a keyword. If I want to read Excel, for example, if it is Excel sheet, I'm not going to read it like that. I'm going to say pd dot read, then I will call whether if it is Excel sheet, then it depends on what I want to read. If it is, there are different, I'm going to tell us different types of data format we can read. And if it is Excel, I'm going to read it based on what I have. If it is, let's say I want to say it is Excel, then I need to read it based on Excel. Like you can see, what I did now is going to be read. Now, these are different types of read: Excel, read feather, read table, read bracket, read preco, read SQL query, read SQL tables. We are going to be exploring this as we move on. But like I said, these are, because I'm using CSV file, that is why I have to redo, say CSV read, that is PD. PD is the pandas here. I can decide to remove as and put pandas.read CSV. That's okay. Then I can decide to use, I can decide to mount it on my file here by reading it directly. But because I have imported it and it is here, that is the reason why I'm reading it like this. So you can see here that I've read now. And I said the next thing is, I want to see the data I have, because I've named this data as df. So I'm going to say df.head. Head simply give you the first 5 lines of that data set you have. That is the line 1, line 2, line 3, line 4, line 5. If you look at this line 5 here, it stops at line 1, line 2, line 3, line 4, line, it stops at Bauchi. And if you look at Bauchi here, this is 1, 2, 3, 4, 5. This is 5. If you look at here, you can see here that we have 5 of them, which is Bauchi. So what does it mean? It gives you up to the first 5 data by using it as df here, like you see here. So it gives you only 5 few words. Now let me go again. What if I want to see the first 20 of this data? if I want to see the first 20 of this data. So that means I will need to pass det.head, and I will pass the number of the lines of the code that I want to see. So I am going to, and now what did I do? I now have to say det, and I pass the first 20 lines of it. Then I will have to see up to 20. What is the line of 20 here in the Excel? The line number 20 here is tabular. What is it here? It is, no, sorry, 20, because it started at 0, so it ought to be 21. So this is 20 here, which is 21 here. So it's supposed to be the total of Kano. Now, if you look here, you see now that because I passed 20 here, it gives me 20. What if I pass 2 to it? What am I going to have? I'm going to have the data read only the first 2 lines that I have in here. So if you do this, what if I say, give me from 2 to put something like this? This is not going to work, because this, you remember this here? And remember why I made this thing like this, to remind you of what we did in set in variable, where we use list. So this is not as related to that. So we should know this. So anytime I want to pass, if I need it in the first 7, and I need just to pass it like this. So this is a way you can see the first side of the data. So this, any word keyword you pass here. What if you say 47? When you know that we don't have 47, what do you think that is going to happen? Because we have about 37, if I'm not mistaken here. This is 37 here, and then I put up to here, in here 47. What is going to happen? So you see now, it read the first data and then cut it from wherever it stops. So I was able to read all the file because it is more than what it ought to be. And this is a way you can assess the length of the data. That's the head, df.head. Now let's go to the second one. Now, what if I want to see the last data? So it's going to be df.tail. Stephanie, did you get your question?
Yes.
All right. So if you want to see the last side of the data, you use tail. Now, if you leave it by tail by default, it's going to give you the last 5 letter of the last 5, or based on the data you see you have. So if you look here, you see what is the last 5 data set we have here. This is 1, 2, 3, 4, 5, and then if you turn it to the right hand side, you see it is between Rivers and Zamfara. If you go there, you will see it start in Rivers and stop in Zamfara. So this is the way you can read the last letter of the word. Now, if it is then, if you put here 10, what happens? It gives you the last 10 data set from behind. It gives you the last data set from behind. So it means it will read from this to 10. So from Zamfara to Ogun State will give you 10. Now this is the way you can read the last detail of the data, even if it is a long to 1 million. If you want to see what is at the end of it, this is the format you are going to use. Now another thing I want to talk again is .info. .info, about that same data we are going to use, is going to give you the information about the data. If you look at it, say the class is score, and then the date is, there are 38 entries from 0 to 37. Now let's go back to the data. This is 37. If you select, sorry, I'm changing the data. If you look at, if I select this thing from here to here, you see that this is, the count is 38 here. Look here, you can see 38 here. So if you return back, you see it shows you that the total is 38 entry from 0 to 37. What types of data? It have 4 columns. Look here, you can see the first is 1, 2, 3, 4, and then it have 4 columns. Then what else do we see again? In the columns, it is written, the first thing we have, the first column is serial number, which is 38. The type of data count, it is integer, 64. Now, the second data title is state. You can see here, this is states. Now, the third data structure we have here is population, 26 and 29. Now, in summary, it gives you that the data type is, there is one integer and 3 objects, which you can see here, And then what is the size of the data? The size of the data is 3.1 kilobyte. So if you go to where we selected the data, what do we have here? 2.2 kilobyte. Now look at here, the item I selected is 1.34 kilobyte. Look at the item we have is 1.3 plus kilobyte. So you can see now this gives you this the information about the data. Now, what else again do we need to look at about reading the file? So we are going to say df dot describe. Now, what does df.describe do for us? If you run df.describe, what does it do? It describes the data for you. Now, here I automatically get the count, the mean of the data, the standard deviation, the minimum is 0, the maximum is 27, the 50% of it is 18, and the maximum is 37. So you can see now that this actually describes the data. So we talked about describe, we talk about info, we talk about tail, we talk about head. So these are different ways you can visualize, see the data. Now, on a quick one, because we are using Google Collaboratory, now let me click on this. This is to convert the data to data frame. So if I click on it, it automatically converts this data into data frame. It converts this data that is in head into data frame. So I'm going to rerun it again and click on it. Now it converts the data into data frame. How? You can see here, it automatically make it look here. You see that it have changed it to this, and then you can see the way it is. I can copy it from here. I can copy table. This is filter, that filter 1 of 5. You can see here. Automatically, if I want to index, if I want to serial number 1 to this, if I want the population of this, if I want to search by all field, I can search by all field by saying Ebony. Look, if I say Ebony, let me make it 100. Now, if you look at as I'm typing Ebony, the state is disappearing. If I remove this, it returns back to normal. As you can see here, I clicked on it and I type, I'm searching Ebony, so it is filtering. Now, if I type the popul index of 1, 12, so this is now becoming interactive. So if I say 12 to 13, and then you can see this is automatically becoming interactive. If it is in the state column, I can, let me clear this, and let me also clear this. And if it is in the state column, I can, anything I type here, it is automatically becoming interactive. So if I click on this, I close it up. So this is the way I can convert it into data frame by clicking on this if I am here, and you see that this is how we change. If I can copy it, and if you look here, you see this is actually for help automatically. If I want to change this, I can say to 50, and then because I use head, the head is still here, because if I use 20 here and then I run the same thing again and I'm able to convert it, you can see the rest of it. If I click on this, it will change it into table and then format it into table where the table are distinctively different. You can see here, I can read through the data completely. Now, this is by clicking on that. Now, the good aspect of this is that it suggests not only that it shows you, but it also suggests a kind of display you can see. You see here, this is the first display here is the distribution. So automatically you are seeing the distribution of using the index here, frequency, and here, and then you can also see the serial number against index. You can see the values here which you plotted against each other. So this is a perfect way you can actually work using Pandas. So let me leave this by default and run it again, and then let's see what happens. Then we have this. Now it is now, this is the way you can, here is to put in data frame, here is to suggest the chart, and here you can say generate a code. Because you are using Google Collaboratory, it is now typing in this format for you. So what happens here, it is using the data frame and it is now getting a code with the data frame. What are you suggesting? It is waiting for me here. Assuming I want to plot bar chart, for example, it says what type of data frame you want to use. Then if I say bar, for example, it is going to now think about this to automatically generate a code that can create a bar chart for me. Now, what did I do? I just say generate and I say bar. If I run this code, I didn't type this code, this automatically going to look for a way is going to create a bar chart for me. So this is a chart that's supposed what happens. So the properties and using this prompt to create a bar chart for me. So this automatically created a bar chart for me. But remember that we are not using matplotlib. So if we bring matplotlib to plot up this, we should be able to have a visualization that perfectly work in for here for you. So if you say I'm using for scatter, for example, let's say let's type a plot that we call line and press enter. Now what happens here, it will automatically read the code. As you can see here, it will bring a code here, and this one say fig.show, and then if I run it now, you can see the plot that shows the line graph for me. It is still loading. Still loading. So with this, you can automatically interact with it and then be able to read the data and then have access to the type of plot or the code you want to generate automatically without you stressing yourself on how to get it done. So this is generally how to work with this such kind of data frame. So I don't know why it is having a delay, but this ought supposed to give us a kind of line visualization that is going to plot states in the x-axis, and then also plot the y population in the y-axis. Do you have any questions so far before I proceed? Yeah, go ahead.
Okay, a question is just I'm trying to understand. You are making use of Google Collaboratory
Yeah,
instead of the normal Jupyter Lab.
yeah,
Sorry,
yeah.
I want to understand is a particular reason for it, or we can
Okay,
just use anyone.
yeah, you might use anyone, but the thing is, as you know, there are some of the limitations that Google Collaboratory have. So one of the reasons why I decided using Google Collaboratory, like I said, is just to like let us get to understand this. So one of the reasons I decided to use Google Collaborate is just for us because most of the work you do, you might not really want to do it on the platform where somebody might not really work. Like let me give you example. Now, this data is actually data analyzed, and I needed a visualization, which we can also do in. We wanted to. You can also do it and upload in GitHub. Now, I needed to plot this as you see here, and I did this for somebody on anticipatory. Now, I this person does not have much knowledge on, but the person just needed a visualization like this where she can use to make analysis. Now, I just decided to use Google this because this is simple, because when I finish, I can just share this code with you and you can see the code as it is written with the analysis just right here. So assuming you want to do such kind of a thing where you just need to import, because I am not trying to show you what you are going to do here alone. You are going to actually use this data to work on different platforms, not just here. So I don't want to only stick you into working on I don't only want to stick you into working on maybe PyCharm or a particular IDE. So I want you to have this ability where you can be here and do other different types of things. So that's why I decided now to put it here. And secondly, today is our first day of talking about Pandas. So I needed you to understand it simply here before we now go into, because installing this, you did not make any installation. But when we go into PyCharm, we need to install, like get different type of thing installed so that we move from basic. Today, our class title said Introduction to Pandas. So I wanted us to graduate from the smaller to the deeper aspect of it. Is that okay?
Yes, it is.
Okay. Okay, so this is like I said, this is a way you can make this different visualization. And then because it is here, you can view a recommended plot like I have shown us here. So this is a way you can view a recommended plot. Now you can see here, this is just for serial number. This is the population of 2006. Now this is a population of 2009. This is a population against serial number. So it goes into the data. This is a correlation, a population that shows 26 and 2019. This is serial number, so you can see the title. So what it means is that as you see it now, I clicked on one of them and it enlarged. So automatically, because this thing is in this format, this is 26 against 2009. So you can see that the population started at 0, but it keep on growing higher until here. You can see the difference between both of them. So this is on this platform, which you can use the way you want it. And then I don't want to go into my credentials. Yeah, so this is the way you want it, and then you can make such kind of visualization here. Very, very comfortable. So this is the way you can access data. This is the way you can check for the information about the data, and this is the way you can make a count on that data. So now here, the difference is the moment you run it, like if I rerun this again or something happen, like we all know, this is going to start afresh. So what I'm saying is that at any point in time, you can use this data, you can access this kind of, use this, and then access the file you have, no matter how big it is. So I'm trying to give us another example of how you can, the different type of data you can access. So what it means is that even if you have a coordinate that you want to plot that have to do with x, y, and then you can actually bring such kind of, the one thing you just need it to do is it in Excel sheet. So once it is in Excel sheet or CSV file that you can access, you can automatically use such kind of data where and how you want it. So that's just my emphasis on today. And then also, you also need to know that the map you need to work on, you can also read the file if the file is in three dimensions, like this type of data we have here. So as you bring in this type of data, have longitude and latitude, it is 3 dimension. So if I open up this, and then it is in 3 dimensions, so all I need to do is to save the data. The data is very, very big, like the size is big, because it's contain a lot of that. You can see here it is about 15 point something gig. So it is 15 point something MB. So if you look at it, see it is very, very big, and that's why it is taking time to open. So you can see the total length is 300 and something thousand. So if I save this as you can see here, and then let me save it on the same location, and then write it 3D map, and then save it as CSV, and then save it here. And if that particular file is completely saved, as you can see, and then I can now go here and then copy the path, the same thing I did before. And if I go this same place again and then run this table, this first one, which helps me to import the data, so I can automatically paste this data as you see here, and then that's going to upload. Remember, like I said, the other data was small, so it didn't take it time to get here. So but if you have a bigger data, you can see now this is loading one after the other. So it have to load like that until it gets to 100. Now when that get to 100, it's going to tell you the name of the file, what is saved. So it means for you to get the data, you have to call the data based on the name you see, based on the name that it is saved here. Like whatever name that it's called, it is what exactly name you are going to use. Then next thing is that the data is going to be uploaded here, because once you finish this, when this goes to 100 and then you refresh this, you will be able to see that this particular data is here. So in when we are going to be using the PyCharm or Google Collaborate, PyCharm or Jupyter Lab, we are going to upload it into a folder we want, and we can call the data anytime we want. And then we're going to be installing different types of like what read CSV and separate the table into CSV, so that at any point in time you can put it up there. And then we're going to be using this CSV in terms of maybe you want to generate a kind of receipt, or somebody buys something and it's supposed to be in a structured data, and they want to automatically generate the PDF, maybe sent to the person email. So we are going to be using this type of structured data. So but what I want you to know is that today is the introduction, and then I wanted you to understand what do you deal with the data, how do you view the data, how do you say this is the summary of the data with speed, without you even also suggest the kind of visualization that could be made with the data. So this is basically what we focus on today. So you can see here it have been uploaded, and then if you come here, this is also here. And then if you go here, what you just need is to copy this 3D map, because that's the name it recognizes, because that's what you save it for. And then if I copy it and I paste it here, as you can see, if I run it here, you see that the data is run. And if I say the head, what happens? It brings me the head. You can see here, this is the latitude, this is the longitude, this is the thickness, this is the density. And if I run this aspect again, that I wanted it to show me the, no, I don't need it. Now here, this is the head, as you can see here. And then if I wanted to show me an interactive data, I can also do the same thing again, and it should be able to give me the data. Now the reason why it's going to fail is because there was no data that's called population, as you can see. Now if I want it to see the head of 1 to 37, as you can see here, this is 47, it's going to give me that. And then I want to run the tail with 10, the last data, you see automatically this is the last data, about 48, as I showed us earlier here. Now if you are the one to read this, it is going to take you time. So you can see automatically it gives us the tail of this particular data. If I want to see the information of the data with quick one, this is the length, this it have longitude and latitude, and it was able to group it like this. What is the size? 12.4. Can you describe this file for me? It will give you the count. What is the mean? So automatically, look at this entire data. I should be able to see what is the count, which is the same thing. What is the mean of this data? This is the mean for the point number. This is the mean for the longitude. This is the mean latitude. This is the mean thick. This is the mean density. This is the mean. The minimum on this data is 6.25. The minimum on this data you can see to 25%, the maximum. So with this you can quickly make a kind of data. And then if you want to make it interactive, you can see here automatically I've turned it into an interactive, a kind of table. And then I can also say suggest a kind of data visualization for me, and you can see these have gone through the data in 2D dimension. In using the values, this is what you can present, and it can give you more other types of data, as you can see here. So if the one I want to do, I can click on this, and then I can add up this particular one to save, and this is the code that is automatically generated, because it have to bring in matplotlibs to be able to give me the rest of the visualization. But if you look at what I'm saying, see, this is just generally how you can interact with data and bring any data in here. So this is the little introduction so we are going to do, and then we are going into switching using PyCharm, where we store the data and we assess what each of the data does, and then we can use this to make a kind of plotting. Because as this now, if I want to plot the longitude and latitude, I can automatically use this data now to make a longitude and latitude with the location and the density point on it. So I can use this particular data to do it scattered the way it is. So as you see here, this is time series that is analyzing, this is the values that is analyzing. So we can make different type of visualization. The same thing we plot in ArcGIS, you can see it have longitude and latitude. We can use that to do contour and then show the thickness or the density of this particular data. So this is exactly how you can bring in and analyze an Excel sheet data or any other data that is in CSV or any other structured types of data.